Hey, it's Plumber Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. Hello, and welcome to this video presentation of the International Mechanical Code, Chapter 10. This is all about boilers, water heaters, and pressure vessels. My name is Thomas, and in this video presentation, we are going to pick up in section 1004, where we'll talk about boilers. Grab your books, let's get to it. As we explored in the last video presentation from this chapter, when you put water, fire, metal, electricity all together, and especially if you decide to create steam, well, there's some real potential hazards to that, isn't there? That's an understatement. So, boilers are required to meet certain standards. What could possibly go wrong? So section 1004.1 states that boilers shall be designed in accordance with the ASME Boiler and Pressure Vessel Code standards. Let's have a look at this. I've broken down what's in that paragraph and put it on a table for you. There are different types of boilers, different sizes of boilers. And those are broken into different standards that they have to meet. For example, if a boiler has less than 12,500,000 BTUs per hour, I know that's pretty big, right? Still huge. It has to meet the ASME CSD-1 standard. However, if it's greater than 12,500,000 BTUs, then it would meet the NFPA 85. Outside of that, we have packaged oil-fired boilers that would have to meet the UL 834, and if it's solid fuel-fired boiler, then it would meet the UL 2523. Does that mean anything to me as a plumber? Not very much. It may be true that I know nothing about the details of those standards, but it's in the code. And these boilers would be required to meet those standards. I should at least know that they exist. 1004.2 states that in addition to the requirements of this code, the installation of boilers shall conform to the manufacturer's instructions. Yeah, we've talked about that before, haven't we? Operating instructions of permanent type shall be attached to the boiler. Boilers shall have controls set, adjusted, and tested by the installer. So when you're dealing with something this dangerous and complicated, it's a really good idea to have some instructions there, right? Especially for the end user, for those operators who will be using this boiler after it has been installed. And they're saying part of that has to be right on the outside of the boiler itself, right? Some specific information. Of course, as the installers, we have the responsibility to make sure that once this is installed, that everything is operational. And there's a lot of things that go into startup, right? There are a lot of controls, a lot of sensors, a lot of things happening with a boiler. So we do have the responsibility as installers to take it all the way through that startup process and hand it off to the user, to the owner, fully operational and in good shape. This section also states that the manufacturer's rating data and nameplate shall be attached to the boiler. So key information readily available. Let's talk about 1004.3, which is working clearance. Every appliance that you install, if you look in the instructions, is going to have minimum clearances. We're talking about water heaters, boilers, anything that uses fire to create heat or heat water. You're going to need to have some clearance so we don't burn the house down, right? When it comes to large boilers like this, there are certain minimums, and the minimum, according to this section, is 18 inches. So lock that one in your memory. You have to have 18 inches around the boiler. Now, the boiler may have more specific clearances. Maybe it requires more space in one area or another. you would obviously go by the manufacturer's requirements, but at a minimum, 18 inches. That gives you just enough room to get around the whole thing, to work on it if you need to view the gauges, thermometers, to access valves, 18 inches. There is another table in this section, 1004.3.1, which gives boiler top clearances. And basically on the top of a boiler, especially large boilers, you see it says boilers with manholes. We're talking like a big old thing you can open up and get down inside to work on it. You need enough space on top of there for that access. So depending on the type of boiler, you can see they're listed out on the boiler type column in this table. The right side column lists out the minimum clearances on top. We see the minimums on there listed out, 3 feet, 2 feet, 7 feet, just depends on the boiler. But you just have to make sure there's enough clearance above to be able to service that boiler. 1005 talks about boiler connections, and 1005.1 specifies the valve requirements. It states that a shutoff valve is to be installed on the supply and on the return for a boiler. Now this is different than your potable water heater, which only requires a shutoff valve on the cold inlet side. Now it's good if you put a valve on the hot outlet side of a typical potable water tank water heater, but when it comes to a closed system like this, you've got supply and return, they want you to be able to isolate that boiler by shutting off both sides, supply and return. In situations where there are multiple boilers, you're going to have multiple shutoff valves. Look at this example. We have 2 modular type boilers. That means there's pieces that you put together to create the boiler. So we see them, there's different sizes here, but they're both connected to the larger primary circulation. Either of those can feed hot water into the system. Modular boiler 1 has valves on the inlet and outlet to the boiler. Modular boiler 2 has valves on the inlet and outlet as well. Here's another example where we have multiple boilers. We have 4 of them here. Each one of them has individual shutoffs for supply and return.
Yes, valves for control.
1005.2 refers to the connection of a potable water supply to our boiler system. If we need to feed that system water, or if we're going to fill it using potable water and we use a direct pipe connection, we need to protect the potable side, right? So this section refers us back to the International Plumbing Code. No surprise, we would be in Chapter 6, Section 608, which is all about backflow prevention. You'd have to have a backflow preventer at that connection point so that we don't get any of that dirty boiler water back into our potable water system. Here's an illustration of that. We have the potable water supply at the top here, and there's several branches, one going to a hot water boiler, another going to a low pressure steam boiler. Both of these have a backflow preventer device in line, right? If we follow one of them through here, we got a shutoff valve, a Y strainer, our backflow preventer. Then we have an isolation valve, pressure reducing valves, another isolation valve. This is a typical series of controls that would feed a boiler system, but we have in that line the backflow prevention in place. The connection to the low pressure boiler is similar. We have a shutoff valve, a Y strainer, our backflow preventer, another valve with a check valve, and a flow actuated valve. That float valve is going to allow water to move through automatically as needed. Check out the version at the bottom of this slide. Why don't we have a reduced pressure principal backflow preventer device like the other 2? Well, that's because it has an air gap. Air gap is a form of backflow prevention. In this case, we can just feed water over, it dumps into a tank, but we have our protection of the potable water. Protecting our potable water source is not the only thing we have to worry about. We have other important safety precautions, and 1006 gives us a lot more information about safety and pressure relief valves and controls. 1006.1, safety valves for steam boilers. 1006.2, safety relief valves for hot water boilers. 1006.3, pressure relief valves for pressure vessels. Now, what's the difference between a safety valve and a pressure relief valve? Well, aren't they all safety valves? Isn't this all about some form of protection? Yes. But let's examine this a little bit closer. What could possibly go wrong? A steam boiler is a pressure vessel designed to generate steam. Could be dangerous. By heating water above its boiling point. The development of steam pressure is directly proportional to both the amount of heat input and the temperature of the boiling water. If boiler controls malfunction, it is possible for steam pressure to exceed the maximum pressure for which the boiler and piping distribution systems are designed. That's where we have our catastrophes. The result could be a violent rupture or an explosion accompanied by instantaneous release of tremendous thermal energy, especially if you're dealing with steam, that's stored inside of there. To prevent such a result, steam boilers must have a protection of one or more safety valves designed to relieve pressure at a selected set point, thus preventing a buildup of dangerously high pressures. Now, a safety valve is designed to open fully whenever its opening pressure or set point is reached. On the other hand, a relief valve will perform the same function as a safety valve, but they do not operate identically. The relief valve is designed to open in direct proportion to the water pressure force acting on its closure disc. Do you see the difference? A relief valve is going to open a little bit. A safety valve is going to open wide, open all the way up. In response to the hazard level, let's consider steam to be one of the more hazardous types of catastrophes we could have. That's where 1001.6 requires a safety valve, the wide opening valve, when we're dealing with steam boilers. However, you can use a safety relief valve, which is like we talked about. It's not going to open all the way up, but you use that on the hot water boilers. Do you notice that they look a lot the same? Yeah, they do. They look a lot the same. I'm flipping back and forth here, right? So the way you can tell the difference is by looking on the tag that's on those, right? It spells out all of the detailed specs of that valve's function. And you want to make sure that you're installing the correct one. 1006.3 gives us that, again, pressure relief valves for pressure vessels. And of course, it is similar to the others, but it opens specifically at a set pressure. 1006.4 gives us some information that relates to all of those safety valves. It says approval for safety and safety relief valves. They have to be listed and labeled. They have to have a minimum rating for the capacity of the equipment or appliance served, meaning they should open up before we have a catastrophe. And the set pressure should not be greater than the nameplate pressure rating. You should be able to look on the nameplate of the boiler, see its maximum pressure, and this safety valve should open long before that. 1006.5 states that valves shall not be located on either side of that safety or relief valve. You don't put a valve before it, you don't put a valve after it, and it should discharge by gravity. From there, we get into a series of specifics on the discharge pipe. We have our relief valve, and we're going to need to convey that water off of the boiler or water heater to somewhere safe. This list is almost exactly the same as what we find in Chapter 5 of the International Plumbing Code, where it talks about the same thing, the relief valve discharge pipe. Let's quickly go through the specific requirements. Follow me closely here. Number 1, the discharge pipe is not to be directly connected to any drainage system. It's indirect waste. Number 2, the discharge pipe shall run through an air gap located in the same room as the water heater. 3, it's not to be smaller in diameter than the outlet of the valve served, and it shall have a discharge of full size to the air gap. So we keep that pipe size all the way. Typical water heater's 3/4 inch threaded pipe. A boiler may have a bigger relief valve, and therefore it would need a larger pipe, matching the outlet size. Number 4, it shall serve a single relief device and not connect to piping serving another relief device or equipment. We can't pipe them together if we've got multiple relief valves just so that we have a single pipe. Number 5, it should discharge to the floor or to a pan serving the water heater or storage tank, to a waste receptor, or to the outdoors. Number 6, it should discharge in a manner that does not cause personal injury or structural damage. Number 7, it should discharge to a termination point that is readily observable by the building occupants. We would want to know if this boiler or water heater is having trouble with pressure, right? We'd want to be able to see that that relief valve is letting water go so we can do something about this. Number 8, it shall not be trapped. Number 9, it should be installed so as to flow by gravity. If that pipe needs to travel a little bit to a floor drain or something, gravity should help it along. Number 10, it should terminate not more than 6 inches above or not less than 2 times the discharge diameter of the pipe above the floor or the flood level rim of the waste receptor. This is typical air gap stuff. Give us a 6 inches. What if I'm running a 1.5 inch pipe off a big relief valve? Well, I'd take 2 times the diameter. That's 3 inches. I have to be at least 3 inches above the receptor where it's going to drain to. Number 11, it shall not have threaded connection on the end of that pipe. We don't want threads that someone could be like, oh, look, it's leaking. Let's put a cap on it. Kaboom. Number 12, it shall not have valves or T-fittings. Just a pipe conveying that water to the drain. Number 13, it shall be constructed of materials listed in section 605.4 of the International Plumbing Code. That's a section in chapter 6 that gives us the materials that we can use on water pipe systems, and it has to be approved and meet the ASME standards. There you go. In this illustration, we see a boiler and a mechanical closet of some kind. There's a high pressure relief valve coming off the side, and there's a floor drain as per International Plumbing Code requirements in that same space, giving that relief valve somewhere to drain to. There are a couple of other important things to keep in mind when we're dealing with the discharge pipe from a safety or relief valve. First of all, if you're dealing with a safety valve with steam, you gotta know that thing's gonna be hot and it's gonna be blowing hard. So you don't want the discharge from that pipe to blast out and to get anyone hurt. That's why we need it discharging so low to the ground so that it's not spraying directly at us as we're approaching it. It is a good practice to keep those discharge pipes as short as possible to avoid friction. If there's a lot of friction in there, it could inhibit the flow and keep that safety device from really doing its job, which is to protect from a bigger catastrophic explosion. So keep them short. Now, this probably goes without saying, but safety and relief valve discharge should not be put out where it could freeze, where the pipe could freeze, the discharge could build up inside of there, because once again, that could block the pipe and eliminate the safety provided by that relief valve. That's all I'm going to say about it for now. 1006.7 is a pretty small paragraph. The title is Boiler Safety Devices, and it simply states boilers shall be equipped with controls and limit devices as required by manufacturer's installation instructions, and the conditions of the listing. That's not a lot of detail. Just have some safety devices. But when I got out the code commentary, it has about 2.5 pages of more explanation on that small paragraph. So let's go into a little more depth as to what this is all about. All right, in addition to backflow prevention devices that we've talked about, as well as safety and pressure relief valves, let's look at some of the other safeties that are built into these boiler systems. We'll start with the high pressure limits. What you'll notice about a lot of these safety devices is that they have a connection to the electrical system, and they have the ability to interrupt the electrical current and stop the boiler from functioning, depending on the situation. The high pressure limit is going to shut down the power to the boiler if the pressure is too high. Similarly, we have the high temperature limiter. This is going to stop the power to the boiler if the temperature gets too high. This is an example of a high temperature limit device that you'll find on a common tank type water heater. It is mounted externally, and if the burn chamber overheats, it will stop the electrical circuit and shut off the water heater. In the process of operation, it is possible for a boiler system to lose water over time. If that water gets too low, it can put the boiler in a very bad spot where there's not enough water, lots of heat, and it becomes explosive. And so we have the low water cutoff. This low water cutoff will sense the water level inside the boiler, and if the water gets too low, it will kill the power. This illustration is more for steam boilers, but it actually has a float device. This is connected to the boiler, and if the water gets to a low point within the boiler, this float valve will disconnect the power and shut off the boiler. Next, we have flame safeguard controls. The point behind these is to detect that there is a flame and make sure that before we allow any further gas or combustion within the boiler, that there's a pilot or some way to ignite that. There are also flame safeguard controls that detect whether the boiler flame is as it should be. If it's not, then it will shut down the boiler. Some of these flame safeguard devices that we're going to look at are very common, and they are installed in more than just boilers. They are in water heaters, furnaces, gas ranges, or gas fireplaces. Perhaps you're familiar with these already, but let's have a look. The thermocouple has been around for a long time and used in many appliances, and it simply probes the pilot light to ensure that it's there. If it does not detect a pilot light, then it will not allow the gas valve to function. Here's an example of a thermocouple assembly connected to a water heater burner. Over time, thermocouples do wear out, and simply replacing them can restore the function of an appliance. A more modern version of a flame safeguard is the power pile generator, or thermal pile. We see these also often on water heaters, but they are used in boilers. These connect to a more complex electronic valve. Similar to the thermocouple, this thermal pile will probe the pilot light. The heat from the pilot light will create a small electrical current. That current will be sent back to the gas valve, which tells the electronic valve it is safe to operate. If the pilot is not there, the electrical current is not there, and the valve will not function. Larger appliances and boilers may be equipped with an infrared or ultraviolet radiation detector in a flame rectification circuit. These sensors are electrically connected, but they detect the flame, and similarly, they will shut off the gas valve if the flame is not burning properly or if it is not there at all. Now obviously, these flame safeguard controllers are going to be detecting a flame. But how do we create that flame? For many years, a standing pilot was the way to light a burner. But now, many appliances use different types of electric ignition, so we can eliminate that standing pilot. A spark igniter, or a direct ignition device, simply creates a spark at the place where the gas is being emitted to the burner. Similarly, a hot surface igniter uses an electric current to create enough heat through resistance to be able to ignite the gas in the burn chamber. A glow coil uses the resistance of electricity to create enough heat to ignite the flame in a boiler. Now this is just a sample of the safety devices that may be connected to the boiler. But the point behind all of this is that if any one of these things are not working, that boiler will not fire. And that's a good thing, because we want a safely operating boiler. All right, check this out. I found this website, Rasmussen Mechanical Services. They service quite a few states around the country. But they have this page on their website about burner flame sensors and safeguard controls. One thing that caught my eye on here was the sequence of operation. Not all boilers follow all of these steps, but the big ones do. Check this out. First, there's a call for heat. Then there's a pre-purge or start blower, so they purge out the burn chamber. Third, the boiler will modulate the combustion air damper from low to high and high to low to bring in enough air. Fourth, the boiler will go into a low fire start switch mode. Fifth, it will start the ignition in the pilot. Sixth, it will prove the pilot, indicating that there is a pilot, usually around 10 seconds. Seventh, the ignition will drop out. 8, the main fuel valve will energize. 9, the flame will be proven. At this point, it's in full fire. Do you see how many steps came before it was opened and fully firing? The 10th step, it will release to modulate. That means that the burn may vary in its intensity a little bit, but when it's done, we have 11, the demand or call for heat is satisfied. It won't heat anymore. And 12, it will go through a post-purge. It's usually about 60 seconds where it just pushes everything out of the combustion chamber. This is fairly involved, and if any of those steps along the way fails, then the boiler will not fire. Hey, have we said enough about safety yet? It's kind of a major theme throughout this whole study. But wait, there's more. So, 1006.8 speaks specifically to the electrical requirements for boilers. Not being an electrician, I won't claim expertise on this, but I will point out some of the requirements for electrical on boilers. First, it has to have a 2-wire grounded conductor. That means a wire going to the boiler and coming away from the boiler. The voltage shall not exceed 150 volts nominal. The controller, that means what'll turn it on and shut it off, should be on the ungrounded side of those 2 wires. There should be a manual disconnect. That means I can flip a switch or do something manually to shut this off. And that should be a lockable disconnect so that we can lock it out, tag it out, work on the boiler without anyone being able to turn on the electricity. And finally, that should have ready access. Let's see if we can illustrate this. In this diagram, we see on the left side a circuit breaker panel. That's going to be your manual disconnect where you can shut it off and lock it. There's 2 wires going to the boiler. The top one has the voltage, that's 120, no more than 150. And it has a switch on that side because that is the ungrounded side. The other wire coming below there is the second wire, and that one would be grounded. It's the neutral wire. And there you have it. Very basic boiler electrical wiring from a plumber. So in this presentation, we have discussed Chapter 10 from 1004 to 1006. Join me in the next presentation where we'll pick it up in 1007 and finish this Chapter 10 in the International Mechanical Code. I'll look for you there. Hey, I'm over here. Thanks. You got me centered? E.